Okay, so is my mic on? I think it is. So, yeah, I'm a little bit under the weather. Hopefully, if you guys laugh at my jokes and stuff, it will pep me up. So, yeah, first, sort of a shameless plug for my 2 books. The one we published very recently is the 3rd edition of Network Security, and in addition to sort of what you would expect, it also talks about what the heck is a quantum computer, why can it factor numbers, why does that break our current things, and what are the new public key algorithms that could replace it. So this talk was sort of inspired by my listening to somebody assert that blockchain with distributed identities solves the identity problem. And so I was thinking, really, what do you think the identity problem is? What do you think blockchain is, and why do you think it will help? So we'll talk about that in this talk. So what is identity? Well, it's a buzzword. And buzzwords sort of drive me crazy, you know, that people start using these words and no one quite knows what it means, or different people think they know what it means, and it's different things. So most people think that they know what identity is. But there's a lot of dimensions to it, like what is your name? How do you prove you own that name? How do I know your name? How do you make human authentication convenient? And what does a browser need to know in order to authenticate a website? So we'll talk about all these things. And then will blockchain solve all these things somehow? And we'll discuss these issues. So names. Names for humans, they're not unique. They should be. Mine is. I'm quite certain I'm the only Radia Perlman on Earth. And you don't have a single name. You have a different username on every site you visit. And it's not hard to have a unique identity. We have many unique names. So email addresses are sometimes used as identifiers. They're sort of unique. But an email address, if somebody leaves the company and somebody else with a similar name comes in, they might reassign the email address, even though in theory you're not allowed to do that. It says in some spec you shouldn't do that. An email address can be shared by multiple people, and it's common for a human to have lots of email addresses. So in a company, the first John Smith gets the email address john.smith. Maybe even John at the company. The next has to be some variant, so Johnny Smith or John.Q.Smith. So if you want to send email to this person, you look in the directory and there's like 7 choices. Which one do you send to? So it's not so easy to delete spam if you know that someone else at your company has a similar name. So with me, you know, I get things that don't make any sense, so I just delete them. But if you have a name like John Smith, whatever looks unintelligible to you might actually be really important for somebody else. But one day I got this email, which you probably can't really see, but it doesn't matter. There's no information there. It's some sort of Excel spreadsheet with a bizarre line in the front. Please refer to below GFXQ, whatever. So I deleted it, of course, because this was clearly nonsense. And then I got it several more times, and I deleted it each time. Well, then eventually, I got it again, where at the top it said, everyone has replied except Radia. And it's like, whoa. So I reply-alled saying, what is this about? And somebody said, please check with SC3 team, and gave me some email address. I have no idea what SC3 team is. So I sent the entire thread to that email address, and I said, do you know what this is about? They said to ask you. And the person said, if I understand correctly, you are asking about the availability of part number PNX HY in COV. So after sort of complaining a few times, yeah, I said, I have no idea what either of these things are. This entire email is totally mysterious to me. And eventually they realized that they had the wrong Radia at Dell. So Outlook, if you type Radia, it tries to fill it in for you. And you know, if you're not paying attention, it will, and nobody would think that there was a different Radia. So I got sort of excited, and I sent email to this other Radia, and I said, "Hi, we're at the same company. We have the same name," and she never replied. So, yeah. So imagine people with more common names. And the way I would solve the problem is if I was a hiring manager, I would be interviewing someone and I'd say, wow, your resume is really impressive and you interview really well, but we can't hire you because we already have a John Smith. And parents would get more creative. So website names. A website has a DNS name like Dell.com. And some registry for like .com administers each top-level domain. And there's like 1,500 top-level domains. So if you want a name and you're a website, you go to one of these 1,500 registries and you try to get a name of .com or .org or whatever. And the website can choose which top-level domain to get a name in. And if a name string within that top-level domain is available, usually the website can buy it. So my favorite website is rentahitman.com, which is a real website. And it was intended as satire. So there's all these like things you can do, like you can type in your credit card and it will tell you whether your credit card is compromised. But they also, if somebody seems actually serious about renting a hitman, they talk to them for long enough to decide, oh, this guy is serious, and then they turn them over to the FBI. So yeah, don't try to get a hitman through this site. And some top-level domains like edu and .gov might insist that you have some reason to actually have that name. But yeah, after you decide, oh, drugs.com might actually be useful, so you get the name and then you hope that people will want to buy it from you for $1 zillion. So yeah, lawsuits and sellings of names and so forth. But let's assume that a website has somehow gotten a DNS name. So the theory is beautiful. So we know how to solve this. We've solved it. So the client says to the website, prove you are x.com. The website sends a certificate. They do cool crypto and cool protocols. And then they have a cryptographically protected conversation. So what could go wrong? You know, the protocol is great, the crypto is great, but in reality, usually the user doesn't start with a DNS name. Instead, they do a search and they get some obscure URL string. So here's an example of a URL string. No human should ever see this sort of thing. And even if you can find the DNS name in here, you can have a DNS name that looks perfectly reasonable to a human. So I fell for a scam recently. I wanted to renew my Washington State driver's license. So I knew it could be done online. So of course, I searched for renew Washington State driver's license. And I got search results. I clicked on the top listed site. I do understand the underlying protocols in crypto, but you know, I didn't really think that the top site might not be correct. So this is what I got. And I'm really sort of sorry that they closed this scam down because there were many variations, you know, dmv.org/Washington or whatever. And since they closed down the scam, and you know, it was for all 50 states and various variations. So, you know, I can't get a good screenshot, but this happens to be what I had clicked on. So it did say add, but that's fine because often the thing that you want, they paid to be first in the search order. So I clicked on it and I got this wonderful website with all these things: renew license, new driver's license, replace driver's license. And these people look so happy. It can't possibly be a scam. So it asked me everything I expected it to, which is what is your address, what's your driver's license number, and what's your credit card number. Now, these criminals were too greedy. If they had just, charged one thing, I would have wondered in a month or two when I didn't get a new license, but it wouldn't have occurred to me that anything was wrong. But the first day they charged $3.99, then the next day $9.99, the next day $19.99, and then the bank fraud department called me and said, are these legitimate charges? At which point I figured it out and I said, oh, okay, yeah, they're not. So the bank disallowed the charges and they changed my credit card number. So I was not harmed at all, but it gives me this super valuable example that shows that there's this, no matter how good the crypto is and the protocols, you're making an assumption that the user will know the right DNS name, and that's not a good assumption. So, there is no security there. Now, I hate it when people blame the users, and they say, well, users, we need more user training, or users shouldn't click on suspicious links. What's a link? What's a suspicious link? So scam sites can appear first either because they pay the search engine, or they know the ranking algorithm and they can game it to be first. So there should be an easy way for users to report scams. So once I knew it was a scam, what do I do? So, there didn't seem to be any way on the search engine to say, hey, this was a scam. So, I happened to know Vince Cerf's email address at Google. So I sent him email, and I don't know if that actually changed things, but eventually this scam got shut down. So the site I should have gone to was www.dol.washington.gov. I, as a human, should not be expected to know that. So in my book, I actually wrote something which, when I wrote it, I said, yes, this is exactly right. People should memorize this. And I've actually seen it on quote boards. So so what I said was, humans are incapable of securely storing high-quality cryptographic keys, and they have unacceptable speed and accuracy when performing cryptographic operations. They're also large, expensive to maintain, difficult to manage, and they pollute the environment. It is astonishing that these devices continue to be manufactured and deployed, but they are sufficiently pervasive that we must design our systems around their limitations. So take that as a challenge that, don't expect humans to learn your thing. Design your thing so that humans can actually use it. So user authentication. We would expect to trade off usability versus security. So you'd expect some sort of graph like this. The more usable it is, the less secure. The more secure, the less usable. But the industry has managed to settle here. Minimally usable, minimally secure. So a human has zillions of username password pairs. How do you cope? If you follow the best practices, you have to have long, complex passwords, different rules for each site. So some sites say you have to have at least 8 characters, others say no more than 6 or whatever. You're supposed to change your password frequently. You're not allowed to reuse passwords. You shouldn't use the same password at multiple sites or similar passwords. So I was sort of reviewing at a university the various research areas. And so there were all these eager grad students presenting their work. And so one of them had this tool that would figure out if you were using a similar password on multiple sites. So I said, well, it's good science, but I hate you. So obviously this is not possible, but creative minds can make it worse. So password rules, they won't tell you what the rules are if you've forgotten your password. It could be that if they tell you the rules, you might be able to remember what you said. And if you forget your password and you go through this annoying alternative way of proving your identity, then you're not allowed to reset your password to what it was before, which was a perfectly secure password if you'd not momentarily forgotten it. And I saw this instruction recently. Password must be at least 8 characters containing at least 1 uppercase, 1 lowercase, at least 1 number, and then it said at least 1 supported special character and no unsupported special character. So security questions, who comes up with these? So these are actually a list of security questions that I was presented with. So father's middle name, nope, father didn't have a middle name. 2nd grade teacher's name, I couldn't remember my 2nd grade teacher's name when I was in 2nd grade. Veterinarian's name, I don't have a pet. Favorite sports team, what's a sport? And my middle name, well, luckily I do have a middle name. It's Joy, so I typed in J-O-Y, and it said, not enough characters. So ways to make things somewhat usable, use an identity provider, which means you say authenticate with Facebook. And then the identity provider, once you've linked your identity at site X, it will vouch for you at site X. So it's kind of very convenient, but if someone guesses your Facebook password, if that's the identity provider, they can impersonate you everywhere. And if somebody breaks into the identity provider, they can sort of impersonate everybody everywhere. So that's kind of scary. The other thing is you can use a password manager. So my browser offers to remember passwords for me, and I go, yes, please, thank you. I love it, and I use it all the time. But that means that, like, if I have Chrome, Google knows all my usernames and passwords in the clear. So if I go to another device and I log into Google, it will know all of my usernames and passwords. So it is kind of terrifying. So another thing you could do is just have a file on your machine with all your usernames and passwords. You could even encrypt it. But the problem is, in order to use it, you have to decrypt it. And once you have this thing of all your usernames and passwords, malware can steal all of your usernames and passwords. So what about biometrics? Well, biometrics are not secret. And if you want to know what my fingerprints look like, just get it off of my water glass. So it's not useful for remote authentication, but it can be useful for unlocking a local device like your iPhone. So now I'm going to talk about PKI. So still crazy after all these years. So public key infrastructure, how do I know the website's public key? Well, the website gets a certificate, which is a message signed by some trusted entity that says this name has this public key. So the way it should work is when the website is talking to the DNS registrar, you have a secure session there. The DNS registrar knows who you are. You've given them your credit card and all that to create the name. But then to get a certificate, you have to go to a totally unrelated organization and say, I've purchased the DNS name rentahitman.com. And how does the CA know that you own that name? So there's a bunch of kind of ad hoc mechanisms for doing this. So why should the CA believe you when you say you want to have a certificate for that name? So one example mechanism is that the CA looks up rentahitman.com in DNS and finds the IP address and then sends a message to that IP address. And if you can receive that message, it assumes you must have that name. Well, if you can, if being able to receive at a specific IP address is secure, why are we fooling around with any of this fancy crypto stuff? You know, just look it up in DNS and send to the IP address. So standards. I'm always curious how standard A compares with standard B, if they're kind of similar things. And nobody seems to do that. So I would like to ask somebody in A, how does it compare with B? And I never get a good answer. But instead, if I ask an expert at A how it compares with B, they say, oh, A is awesome and B sucks. And I ask the B person, I get the opposite answer. I'm sort of reduced to looking at these two specs, you know, long, badly written specs with their own jargon for no good reason. And then if it turns out that there's things about B that are better, no problem. The A committee is perfectly happy to steal the ideas. So, you know, both A and B are moving targets. So it's kind of natural to think of these standards bodies as well-educated technologists that are carefully weighing engineering trade-offs. But I claim a more accurate way to think of them is as drunken sports fans, you know, rah, rah, my team. So here's an example where instead of inventing something new, which is what standards bodies do all the time, there's a perfectly reasonable thing, but they decide they want to invent their own thing. Here, a standards body adopted a syntax which was invented by a different standards body, which just never happens. So ordinarily, I would applaud them, but in this case, the certificate format, a certificate matches a name to a public key. How simple could that be? So the IETF, which is sort of does the internet standards, they decided to base certificates on X509, which was an ITU standard, different sports team. So why should it matter? Well, the problem with X509 is that it maps an X500 name to a public key. So what's an X500 name? It's a perfectly reasonable hierarchical namespace. So it looks like each component has a type. So it might be C equals country name, O equals organization name, OU equals organization unit name. You can have as many of those as you want. And then CN equals common name. So that would have been fine if internet protocols and users were using X500 names. But they don't. They use DNS names like example companyname.com. So what good is something that maps some string that the application and the user is unfamiliar with to a public key? So here's an example, humantypesfoo.com, you know, some sort of DNS name, or clicks on a URL that contains the DNS name. So the site sends a certificate with an X500 name, like C equals US, O equals Attica prison, OU equals death row, OU equals particularly vile prisoners, and CN equals horrible person. So what did early implementations do? They said, well, different syntax, I can't match what the user typed to what's in the certificate, so I will ignore the name in the certificate, but I will verify the math, and I'll look at things like the expiration date and tell you whether it's secure. So what security does that give if you don't care about the name in the certificate? Just the warm, fuzzy feeling that someone paid someone for a certificate. So people invented at least 3 different ways of encoding a DNS name into a PKEX certificate. So one was to come up with a new category. So instead of C equals whatever, they had them all be DC equals, which was domain component. So you could say DC equals com, DC equals Dell, DC equals labs. Or there's a field in the PKEX certificate known as alternate name. So you could put the DNS name there. Or you could use the bottom of the X500 name, the common name, and put the DNS name there. So are 3 ways better than 1? No, because suppose a CA makes sure that you own the DNS name that you put into the alternate name field, but doesn't care about, you know, the other things. And suppose a browser is looking at the encoding of the DNS name in a different way. So I have no idea whether all browsers check all places and whether the CA checks all places. So trust models for PKI. So this is sort of another thing I'm kind of passionate about. So yeah, PKI has digitally signed messages that signed by some trusted thing vouching for what public key goes with what name. So it basically says, I, the CA, vouch that this key belongs to the name Radia. So we use this when we're using HTTPS. So I'll talk about all these models. I'll have sort of slides on each one. So the first model I called the monopoly model, where you choose one organization universally trusted and beloved by all countries, all organizations, et cetera. And you embed their public key in absolutely everything. And you give them permanent monopoly to issue certificates. Well, and everyone has to get certificates from them. So it's simple to understand and implement, but what's wrong with this model? Well, there's monopoly pricing, sort of the more widely deployed where everybody is configured with your public key. If you're the universally trusted CA, the harder it will ever be to change to a different key. And getting a certificate from a remote organization will be insecure or expensive or probably both. And the more widely deployed, the harder it will ever be to swap out their key and choose a different organization or even have them change their key. And that one organization can impersonate anyone. So we can do worse. This is what's in your browsers. I call it the oligarchy of CAs. So it comes configured with hundreds of trusted CA public keys. So your browser will believe a certificate signed by any of these 500 organizations. So it does eliminate monopoly pricing, but it's less secure because any of those organizations can impersonate anyone. And this is what we use all the time. So beyond oligarchy, there's certificate chains. So a chain is where the public keys that are configured into your browser are known as trust anchors. So you can go to a website and instead of having it, its certificate signed by one of your trust anchors, it can actually present a bunch of certificates. So let's say that X1 is a trust anchor at the client, so the Bob can give a chain saying X1 says this is X2's key, X2 says this is X3's key, and X3 says this is Bob's key. So now I'll talk about anarchy, which is also known as web of trust. So what it is that nobody tells you who to trust. You configure your trust anchors as just you've met people, they seem trustworthy, you configure their key into your machine, and then every time you have a gathering of nerds, like an IETF meeting, there's some sort of PGP key signing party with some sort of elaborate ritual where you say who you are and what your key is, and people can vouch for you. Yes, that is John Smith. And anyone can sign a certificate for anyone else. And there are public databases of certificates that are both world readable and world writable. So world writable means that you can donate whatever certificates you've signed into the public repository. And world readable is so that if you want to get the public key of some name that isn't a trust anchor, you say, well, is it configured into your machine? And if not, then you have to try to find a path from one of your configured trust anchors through certificates in the public database. So the problems with this anarchy model is that it's not going to scale. You can demonstrate it by having it in a reasonably small community of all trustworthy people. You say, look, it works. But if you imagine opening it up to the entire internet, then people can start putting in bad certificates and stuff, and there's no way for a human, it's just going to be too big. So imagine 1 billion users, everyone signs on average 10 certificates. That's an awful lot of certificates to have to kind of paw through in order to get to the name that you want. And there's no way to tell if that particular path should be trusted, even if by some miracle you find a chain that mathematically works. So with this model, more or less anybody can impersonate anyone. So now I'll talk about how I think it should work. So the first main concept is that you shouldn't think of a CA as trusted or not trusted. Instead, you should say, I trust this CA for some subset of the names. So the name by which you know me implies who you trust to certify my key. So if you know me as Radia Perlman Dell.com, you would trust a CA associated with the namespace Dell.com to certify my key. And if it's, Roadrunner279 socialnetworksite.com, you would trust socialnetworksite.com to certify my key, and so forth. So whether these names are the same carbon-based life form is irrelevant. You could use different public keys for each one or the same one, it doesn't really matter. So to do this, you need a hierarchical namespace, and we have it. It's called DNS. So each node in the namespace is represented by a CA. So when you hear this model, everyone thinks of the top-down model, which is everyone is configured with the root, and then the root signs .com and .org, and .com signs xyz.com, and so forth. So you just follow the namespace down. So everyone is configured with the root key. It's easy to find somebody's public key. You just follow the namespace. So the problem is there's still a monopoly at the root. The root can impersonate everyone. And here I'm going to get to the model that I actually like. So it was invented by my co-author, Charlie Kaufman, around 1988. So there's two enhancements, up certificates and cross certificates, and I'll explain what each of those are. So up certificates is where not only does the parent certify the key of the child, but the child certifies the key of the parent. So you don't have to start at the root. So for instance, at my company, I'm sure that the IT department would configure all of our machines to start at Dell.com. And if you're in the namespace Dell.com, you just go down. And if you're not in that namespace, you have to go up until you get to an ancestor of the name, and then you go down. So what do these up certificates add? Well, the trust anchor doesn't need to be the root. And to get a name within Dell.com, if your trust anchor is Dell.com, you just follow the downlinks. And to get names outside, then you have to go up until you get to an ancestor. So that means that the CAs that need to be trusted in order to authenticate between resources in the Dell.com namespace are all controlled by Dell. So, yeah. So, the CAs that need to be trustworthy are all controlled by Dell. So it hasn't had a joke for a while. So the difference between trusted and trustworthy is that if something is trusted, it means it can screw you. And if it's trustworthy, it means it won't. So anyway, so also useful are cross certificates, where any node can certify any other node's key. So there's two reasons for this. One is you don't have to wait for the whole PKI for the world to be connected. You can build a little PKI in your organization. Another organization can build a PKI. And if you cross-certify, the tops of their organizations, then you can, everyone in one namespace can get to the keys of everyone in the other namespace. The other reason for a cross-link is that you can bypass portions of the PKI that you don't trust. So for instance, if that little subtree at the bottom of the arrow doesn't trust qvj.com or the root, it can create a cross-link so that people in that namespace will go directly to xyz.com and go down. So a lot of people think, well, you just said that you don't like the anarchy model and you've just reinvented it. And no, you only follow a crosslink if it leads to an ancestor of the name. So you'll only follow one crosslink and then go down. So you don't follow a crosslink to explore whether HP might know how to get to IBM. So the advantages of this is to build a PKI in your own organization. You don't need to pay a commercial CA for certificates. And security within your organization is controlled by your organization because you can manage your own CAs. And no single compromised key requires massive configuration. So you might think, well, what if the root key has to change? Well, me being sort of at the bottom of the Dell.com hierarchy, I don't have to change my key. I don't have to change my certificates. Just somebody at the top of my organization, Dell.com, has to do the magic of revoking the old certificate and whatever. It doesn't affect me. So it's easy to compute paths. The trust policy, I think, is very natural, and it makes sense. And malicious CAs can be bypassed and damage contained. So the bottom-up model almost got adopted. It was implemented in Lotus Notes, which isn't that surprising because Charlie was the security architect for Lotus Notes. And then he went to DNSSEC for a while and got them to put in the cross links and the uplinks, and then he stopped going because he achieved his goal. And then a few meetings later, apparently someone said, what are these here for? Can anyone think of a use of them? And nobody at the meeting spoke up for them, so they got removed. So DNSSEC is top down. Everyone sort of has to start at the root. Now PKIX, these kind of X500 things, it does have name constraints in the certificate, which is great. You can do anything you want with it. So if you want to create a child link, you'd say, I only trust this CA for their name and below. And if you want to do a parent one, you say, I trust it for everything except my name and below. And a cross-link would be just like a child link. You say, I trust this for this namespace. But yeah, so it's great. It's in the certificate, but nobody seems to implement it. So it might as well not be there. So what we have today, PKIX is oligarchy. There's zillions of CAs that are completely trusted for all names, and that doesn't seem very secure. It does have the name constraint field, but since people don't implement it, it's not, it's kind of useless. And what if a company wants to provide lots of services like laptops.company.com or itconsulting.company.com? Well, these days, you either have to get a single certificate for a single key signed by a commercial CA for company.com and put that private key in all of your services. Well, that's not really very secure. You don't really want to copy the private key all over the place. Another thing you could do is pay a commercial CA for every one of those names. You know, laptops.company.com and get a different certificate for each one. And, or the company.com can try to be one of these trusted CAs, but that's kind of dangerous because if anyone misuses that key and, you know, they could do unlimited damage. So, you know, a company doesn't really want to do that. So too bad you can't get a single certificate that says you are a CA, you are allowed to sign certificates, but only for the names of the form star.company.com. So DNSSEC is name-based. So a company can sign certificates in its own namespace. So I sort of, in a DNSSEC working group, I was talking about what a fan I was of DNSSEC and how it's a much more sensible PKI. And they go, shh, Radia, don't say that aloud, because if the PKIX people thought that we were a competitor, they'll shut down our working group. So yeah, and it's not certificates per se, but you can have a public key advertised in DNS, and you could sign things for your children. So it's kind of the same thing, but actually much more lightweight. So yeah, certificate expiration rant. Why do certificates have expiration dates? If somebody steals a site's private key, they can, you can't rely on the expiration date in the certificate. You can do a lot of damage in hours. So is the point to annoy and frighten users with, weird error messages about this is not secure? And yeah, it does accomplish that. So Google has announced a policy for 90-day expiration. So this is way too long to be safe, and it's super annoyingly often, the overhead of doing all this. So the only real solution is a revocation mechanism to somehow say, this certificate, don't believe it anymore. And the industry has known for decades how to do revocation. There's sort of two mechanisms. One is a CRL, certificate revocation list, where the CA who signed certificates posts something that says, here are a bunch of certificates that I signed that don't believe them anymore. Or OCSP, which is Online Certificate Status Protocol, where your browser can go check with some online server to say, is this certificate still valid? So there's nothing mysterious there. But if this, I don't know how widely it's deployed, but if it were widely deployed, then we wouldn't be talking about making certificate expirations be much shorter. So what is the reason for this? Well, again, if the problem we're solving is guaranteeing a revenue stream for commercial CAs, that's sort of why you should have them expire. So now I'm going to talk about blockchain. So I heard this assertion that distributed identities using blockchain solves the identity problem. So what is blockchain? Well, it's not actually well defined. The engine behind Bitcoin is well defined because it's a thing, but there are so many different variations of blockchain, like a private blockchain or blockchain as a service all managed by one organization, in which case it doesn't have the same properties that, like Bitcoin's blockchain would have. So one way of thinking of blockchain is that it's a magic thing that solves everything, especially if it's related to security. And a more realistic thing is it's just an append-only database that's world-readable, and it's stored and maintained by lots of anonymous nodes very expensively. So distributed identity using blockchain. So I've simplified the concept down to what it really is conceptually. So names are hierarchical in this system, where there's something that says which namespace, which is just like the top-level domain in DNS. And then, so you have namespace ID and the rest of the name. And each one of these namespaces has its own blockchain. So what you do is if you want to get a name within a namespace, you look through the entire blockchain for a string that's not yet used, and there's nobody in charge, so you can choose any name you want. And so you put the name you've chosen and a public key on the blockchain. And so now you have that name. So what subset of identity is this actually solving? Only obtaining a name and asserting its public key. But getting unique ID is not a problem. We have lots of unique IDs, several email addresses, your Mumble handle, whatever it is today, your username at each website. And then if you say, DNS is kind of centralized and that's evil for some reason, it's not. DNS is somewhat distributed because you can choose which top-level domain to work with. And a public blockchain is very expensive, among other issues. So names now become meaningless strings, even more so than today. So sure, you got a unique name. How do I know your name? So it also doesn't say how to map this name to a DNS name so that you can look up somebody's IP address. So it does avoid CAs, because if whoever claimed a name also puts a public key on the blockchain, and in theory that the blockchain can't be modified, you don't need certificates. But since the name is a meaningless string, you could have just used your public key as your identifier. That will be unique. And you could bypass certificates and blockchain entirely. So it's way simpler and less expensive to just use your public key. So what doesn't it solve? Mapping between a name and what a human wants to talk to, or mapping between this syntax and the DNS name, so that you can look up the IP address, or maybe you invent and deploy a whole new DNS-like thing. The user remembering their own private key or other credentials, or revocation. What do you do if your private key is stolen or you forgot your private key? So I was giving a talk and somebody said, oh, they have a solution to that. And I said, really? How does that work? And so he showed me a spec someplace. It said, saving the private key is essential. You can't lose it. All access and control will be relinquished. Don't lose a private key, please. So the solution is ask users very nicely not to lose their private key. So nothing is quite right today. Names really are meaningless strings. Getting a certificate is messy and insecure. The trust path of certificates is kind of messy. And either we should universally implement the name constraint in PKIX, or we should deploy DNSSEC. Human authentication is unusable and insecure. And whatever it is, blockchain and distributed identity is not going to help any of these things. So it's amazing things work as well as they do, but there's still gaping security and usability issues, which is good because you guys want to solve things, and like we've left you with this mess, so there's plenty of places you can add value. So final rant. Some hyped, ill-defined thing suddenly appears, and then people don't want to miss out. It might be the next big thing. So they want to do that, whatever that is. So my advice is don't just sort of jump on some hyped buzzword. Instead, start with what problem are you solving? Look at various ways of solving it, including what could you do today to solve that. Compare the approaches and choose the best one, and that's what you should build. So somebody once came up to me and said, well, that sounds good, but the problem is my manager really wants me to use blockchain. So I said, fine, do what I said, look at various possible solutions, choose the best one, build that, and then tell your manager you're using blockchain. He'll never know the difference. So this is sort of an anecdote that will make you forever remember that you should know what problem you're solving. So in my book, Interconnections, I have these little boxes that I say real world analogy. So I like talk, in the scaling thing, I talk about the wine glass clicking protocol that works fine if you have like 5 people, but if you have 11 people, everyone has to click with everyone else. It's, it gets really awkward. So the one that is absolutely everybody's favorite, and it's 100% true, is where I was trying to illustrate that you should know what problem you're solving before you try to solve it. So, which is a real problem in this industry. People sort of, vaguely know what they're trying to do. They write code, it doesn't work in all cases. They add more code. So the anecdote that will forever make you remember this is that when my son was 3, he ran up to me crying, holding up his hand saying, my hand, my hand. So I kissed it a few times. What's the matter, honey? Did you hurt it? And he said, no, I got pee on it. So thank you.